Yeah, sorry. So we thought we are just doing some fun stuff, or at least it was fun for us. more fun for David than for myself, because he is doing all this cool stuff. And actually, we are doing some interesting things about IoT. And people who were here last year already know this nice thing. The question is, if you're doing IoT, is it serious, or is it more like fun stuff, which is has not really any purpose? And
Do you need some help?
It's better now? It's better now? Yeah. I can hear myself. That's good. Okay. So, yeah, what I was saying is, if you're doing IoT, is that serious, or is it more like being an idiot on the street? And if you think this ties into a little bit what I said earlier on, about what is happening, people have all these smart devices like watches, smartphones. You can have sensors at home and all these things. So it's really, the world is changing. You can have things like the Amazon Echo or the Google thing you can talk to. And I guess people of us who are a little bit older, like I am, might remember this TV series, Knight Rider, right, where Michael Knight was talking to his watch, and then the car was coming towards him. Like 20, 30 years back when this TV series was on, it was really science fiction. But actually that stuff is true today, right? You see manufacturers of cars doing exactly these demos. So you can go out of your house to your front door, call your car, the garage door opens automatically, the car drives up to you, you get into it and say, drive me to the next pub, and that's all you have to do. So these things are pretty serious. And we thought, let's do a nice demo, which is not as cool as having a self-driving car here, but I hope it's still cool enough. So as you might know, my name is Carsten Ziegeler. I'm working for Adobe Research in Switzerland. I'm principal scientist there on the AM Foundation team. I'm also the VIP of Apache Sling, Apache Felix, and involved in the OSGi Alliance and the specifications. And next to me is David Bosschaert. He's also working for Adobe, based in Ireland. He's actually the EG chair of the OSGi Alliance, so the chair for the enterprise expert group, involved in a lot of open source projects like Felix, Arias, and so on, and also was part of the ISO cloud, I always forget that one, cloud computing group, right. I believe. So let's go with David and start the talk.
So, yes, so let's talk about IoT and how we can use OSGi to model what at least we think is a more real-world IoT example that that can actually be useful in for people like you and me, like everybody. And it's about saving energy. I mean, everybody likes saving energy, and I think this is a good use case for IoT. So for people who were here last year, this kind of demo, it starts maybe a little bit similar than last year, but it's an entirely different kind of area, and we started looking at some new technologies in that context as well. So is this an idiot example, or is it a real IoT example? We'll leave that to you to decide at the end of the talk. But this is basically what we have, right? We have a whole bunch of devices, and you want, they might all be in your home, and you want to connect those to a smart backend, something like OpenWhisk. How do you do that? How do you get these things to connect? The problem is that all these things have very specific protocols. Often they're kind of near-range protocols, very specialized in what they want to do, low power, maybe certain kind of frequencies that go through thick walls or something like that. So you have all these specialized For that, you need a gateway to concentrate all these things before they go into the internet, because they can't talk to the internet directly themselves. So obviously OSGi is a really good way to do this. OSGi has been designed from the ground up, basically to fulfill this function, and especially since now these devices are so much cheaper, it becomes a really handy tool to create an internet gateway. So why is it useful? First of all, it's a unified and open platform. It's a standards-based. You can add your own stuff in there, but you can also use standards APIs. There's the service registry integration point. Service registry is a great way for providers and consumers to find each other without having to know a priori who they are. The OSGi Alliance has defined a whole bunch of IoT-based APIs. We're going to look at those in a few minutes. So they are there to be used. And then OSGi itself has already kind of been proven to be a great platform for sharing and reusing technology. Like many of you know all the Apache Felix components like config admin or event admin, or there's a whole bag of OSGi components that are shared across many technologies by many people, and OSGi has been quite successful at that. Then there is quite a bit of tooling around OSGi, for example, around provisioning. So you get that for free, more or less. And then finally, which is, I think, a really important piece, is that OSGi is dynamic. So it is really designed to deal with situations where, for example, you plug in a new kind of internet-capable coffee machine, and the dynamics can handle all of that. So in this example, we're going to basically look at central heating. And I'm looking at, there's going to be more details later, but basically the idea is that if it's winter, you need to heat your house, but you're not going to be in all of the rooms at the same time. So why don't we kind of put some motion sensors in the various rooms? These are the motion sensors that we're going to be showing later on, that basically know when there is someone in the room. And that basically, based on that information, they can switch on and off the heating, depending on whether there are people there. And then, obviously, if you have, a direct system like that, that's not really so convenient, because they might switch on the heating as you walk in, which is kind of just too late. So that's where the OpenWhisk backend can come in to make that system a little bit smarter. So let's have a look at an OSGi technology that is really good for modeling this, and that's the OSGi Device Abstraction Layer. So that's a technology that's defined by two specifications, and basically it allows you to model a radiator thermostat, like this one, for example. And what you get if you have a driver for a radiator thermostat in OSGi DAL, you get a whole bunch of services. So you're not exposed to the low-level kind of wireless API that the thing might be using. You get OSGi services, and you communicate with the services, and by doing so, the driver will basically do the low-level talking for you. So for this example, you get, each device gets a device service. There's one per device, so you know that it's there. Gives things about, whether it's connected or not, some basic information. And then, additionally, you get some function services. And these function services allow you to read stuff out or write stuff to the device. So the Z-Wave device, a radiator thermostat device, for example, has a multi-level control temperature function, which basically is as simple as setting the temperature. So you can set the temperature to 21 degrees or something like that, or to 10 degrees. But it has another function as well, which can be quite useful, and that is to tell you whether the battery is nearly empty. And I find this one of the most useful ones. So you can read that out. It's purely a read function, and it saves you from walking around the house checking the batteries every couple of months. And just to give you an idea, I don't expect everyone to read the whole list or being able to remember this, but just to give you an idea of what you get out of the box with the OSGi specs in terms of IoT support. There are a bunch of data types that are defined by default, like there's an alarm, for example, when your smoke detector goes off, Boolean read and write data types, sensors and control, keypads for, those security keypads, a meter data type, which is used for electricity meters, for example, and then there's like the multi-level sensor and control, and there's also a wake-up one. And you can define your own as well. And they've defined a whole bunch of function types that relate to specific types of devices that are out in the market, like fire sensors, gas sensors, heat sensors, humidity sensors, but also things like window open and close functions and stuff like that, and of course the temperature functions. So let's build our demo based on this. We can start with a very simple demo that's not yet smart just yet. That is basically having these motion sensors, and when Carsten will walk through the room, we can see that the radiator thermostats here and there will basically pick up his motion, and it uses these OSGi DAL functions to control them. Now, originally, I was actually planning to use the real Z-Wave radiator thermostats, but they're very hard to show anything in a demo. So I got these ones with lights on it, so you can actually see something. Okay, but before we show the demo, I just wanted to show how easy it is to build something like this using OSGi APIs. So this is like a declarative services component. Who in the room is familiar with declarative services? I guess, that's a good half of the people. So that's basically an annotation-based way of using OSGi. And what we have here is a very simple component that listens to events. So whenever an OSGi device abstraction layer sensor is changing, it sends events through the event admin pipeline. And you get these events like property changed. So this one is subscribed to the property changed. I'm not sure if I can show. Yeah. So this is per one. So that is like infrared motion detector 1. When that one receives a property change, I'm going to call handle event. And that handle event basically works on this radiator function that got injected through a GS as well. So it's really as simple as when the motion sensor says there is motion, then I'm going to, or if there's no motion, if there's a change, then I'm going to set the data on the radiator controller, meaning that if there is motion, I'm going to set it to 21 degrees, otherwise I'm going to set it to 7 degrees. All right, so let's start the demo. Let's see if I have everything here. Okay, so I'm going to hold up. Now this, this is the moment of truth. I'm going to hold up these PER sensors, which are quite insensitive because otherwise they would always go off. So if Carsten starts walking on that side, then we might see some radiator switching on. And then when he moves away, then you can see that but this is, it worked. So this is already kind of, very simple, gluing the pieces together, but there's no intelligence yet, because as soon as Carsten walked out of the room, the radiator thermostat switched off, and that's not really practical in real life. So let's talk about making it smarter.
Right. And with this demo, you could actually see who of one is the idiot, who of us is the idiot, and who does the cool stuff. Right, so this was the demo. So what we've seen here actually is exactly what David described. We have the gateway with the DAL, the device abstraction layer service talking to these devices. And now, how can we make this a little bit smarter? And usually nowadays, if people talking about making things smarter or making it better or whatever, they're trying to have less service. Before we get into that, now usually this is, you always have to deal, when you're writing a famous, good working web application, you have to deal with traffic spikes, like you want to survive the Super Bowl effect, right? So during normal operations, you just need 1 server, 2 server for your application running, but then there's this huge event once a year with the Super Bowl, and out of the sudden, your server gets stormed with requests, and obviously you want to scale up at that moment, or obviously a little bit before that moment, so you can cope with the amount of requests. But once that Super Bowl is over, and luckily it's over once a year, you want to scale down again because you don't want to waste resources over time. Now looking at the at the history of what we see in the IT landscape is, back in 2000, we had physical hardware where administrators were really taking care of this hardware and installing their servers on these things. Then we moved on to virtualization, where you have VMs, where your servers are running in VMs. And then, of course, some years ago, the container concept came up famously with Docker, and that's supported by all the famous public clouds. So you're really running your application in a container, and you just take care of your container, and you don't care where this container is really running on what hardware and all these things. So it's really one step further in the virtualization. And since 2016, maybe a little bit earlier, the concept of serverless came up, where basically you're just defining functions, and these functions are executed somewhere, and you don't really care where they are running. And for example, the Amazon Lambdas is one thing, one example of serverless, and Microsoft has the same concept, just slightly different, of course. And there's Apache OpenWhisk, which I will get to in just a minute. So with serverless, you actually have function as a service, or FaaS, which sounds a little bit strange to me, but again, that's just the acronym for that one. It basically means you define your logic as a function, and that function is executed and gets triggered by some event, by some trigger. This could be a web request, but this could also be a cron job or someone walking through the room. All these things could just trigger execution of a function running in such a serverless environment. And with these functions, you can scale as needed. Right? So that's one of the basic concepts. And apart from the solutions that are offered by the cloud vendors like Amazon or Azure, you can use Apache OpenWhisk, which basically allows you to run a serverless infrastructure within your own data center, or within your own cloud, or with your own company, or wherever you want to run it. You could even run it on your desktop. Maybe not on a Raspberry Pi, but at least on a desktop. So with Apache OpenWhisk, you have this central thing where you can just deploy functions. These functions can be written in various languages. You could write them in JavaScript, and then it's running in a Node.js environment. You could write it as a Java class and then do stuff there, and there are other options. You could even come up with your own thing of running functions if you want to. With that, you get some nice tools, like a command line tool where you can just deploy new functions, you can test your function, and then all these things. There's an IDE support, and you also have a nice UI. You can test out this stuff. But of course, in production, you don't want to go to the command line and type in some command to execute the function. You can define triggers, which then executes functions. So for example, in our use case here, if I'm walking into the sensor and the sensor detects me, this triggers then the function execution in the serverless environment. And of course, from the functions you develop, you can talk to other systems and invoke stuff there. So this is the basic building block that OpenWhisk gives you. So if you install it, so how does it tie into smart home logic? I think we have some nice marketing titles here, smart home logic. Anyway, so how could you use this functionality of serverless in such an environment? Now, whenever, at least today, or for the last one year, or maybe a little bit more, when someone talks about something clever, some cool algorithm or whatnot, then it's about machine learning. Maybe even artificial intelligence, but it's most often machine learning. So we thought about just doing some machine learning stuff in OpenWhisk in a serverless way. So we have our motion sensor. We have this gateway in between, which collects the input from a motion sensor. It also gets different data, like the current outside temperature, the current time. So whenever someone is detected by the motion sensor, you know when this happened. And this data is collected, first of all, by the gateway, which is running local in your home. And that gateway pushes all that data out to OpenWhisk. It basically invokes a simple function there, which is serverless, and that function stores the data in a database. And once all this data is in the database, you run this machine learning algorithm on the data, and it creates some kind of prediction. So for example, if you're entering the room every day at 5 o'clock, after you did that for some days, this system will know that you will eventually come up at 5 o'clock at the next day, so it will maybe turn on the heating already 4:45. And when you enter the room, it's already warm. Right? So it's machine learning as its best for these things. Now we have all this stuff running in OpenWhisk and can do this. And basically what then the gateway is actually doing, it's talking to this prediction algorithm, which is again is a serverless function running in OpenWhisk, and then decides based on this prediction function when to turn on the heating or when to turn it off. And that's basically all it needs to get some cleverness, some smart logic into your home. Right. So this is basically one setup of doing things. I mean, of course, if you think about this use case, it might not be the best use case for machine learning, but this is just to give you a picture of how things in general could fit together, like collecting data in your smart home, having this gateway which collects that data or assembles that data, pushes it out to OpenWhisk, to some serverless server, which then executes these functions, and then you have some really clever logic running in that serverless environment. And you could use machine learning in that, or do something else, like simply generating random numbers if you want to. And the nice thing, if you're following this pattern, is that this gives you a lot of flexibility in the end. So you don't have to use a serverless infrastructure and a cloud running somewhere to be able to build the system. You can simply start by developing your OSGi bundle, which has some logic, and simply run all of this, including a small database in your gateway. Right, this is more or less what we did in the first demo, more or less. This is one way. So really, you have everything running within your home or your own location. But then, of course, you could think about scaling this out because you need some heavy calculations, some additional information or whatnot. And you can scale it out to a remote OSGi framework, which basically allows you to run the same bundle that was previously running in the gateway in the remote framework. You use the OSGi remote service to call to that service. And you don't have to change anything in your gateway. It's just a matter of provisioning your OSGi bundles. So this gives you already more flexibility or more power, if you will. And you can, of course, start running this in some cloud infrastructure, which might give you scaling as you're running this OSGi framework in a container and all these things. Or you can go one step further and run this OSGi framework as a function in OpenWhisk. So basically, instead of writing some JavaScript that implements your function that you want to run, you could write a service in OSGi with a method, and this one gets called. So basically, if you're invoking or triggering such a function in OpenWhisk, an OSGi framework is started, your bundle is started, your service is started, and that method is invoked. This might sound a little bit heavy, but in fact, I guess it's not really that heavy. It depends on what you do in the OSGi framework when it's starting. And actually, OpenWhisk has a concept of initializing your functional environment and executing it. So even if it takes a little bit of time to get that thing running, OpenWhisk will already do it before that function gets invoked. So this is all fine. And with this, you have all these, you have all the flexibility when you're using OSGi to implement your smart home on where you put things. It can run in your gateway at home. It could even run in your device, maybe, or you can just move it to the next stage, so to say. And with this, I think we have explained the basic thing of using serverless in these things. I'm not sure, do we have an additional demo?
We do have an additional demo.
Do I have to walk again?
Yes, I have to. You have to do the catwalk again, Carsten.
I do my best. I do my best.
So what I need to do is the actual OSGi Gateway is actually running on a little Raspberry Pi that I have here. And what I have to do is I have to enable this, the backend, the intelligent gateway support that can be used to talk to OpenWhisk. So I'm starting an additional bundle for that, and this basically adds the service. And with this, basically, we added some usability that if you walk into a room and you walk out, that the central heating doesn't immediately is switched off, but it basically stays on for another like 15 minutes. So let's see if that worked. Carsten is walking into the first room. So I think if it worked, then both of them are still lit up. Yeah, so they are. This means that the additional service that is using OpenWhisk basically told the system, no, don't react to the motion sensors right now. Keep the heating on for another little while.
And now we wait for 5 minutes until the light goes out.
Right, 15.
Oh, 15. Oh, sorry. Even better.
Okay, I think that was the second demo, really short. And I think that is we have.
So yeah, as you can see, or hopefully could see, this is a lot of fun doing IoT, and I think the basic idea of our talk is really to give you an idea what could be done, and then to basically make you think out of the box of the general Sling AM things, and think about use cases for these nice things. Because, for example, it could be useful to install these things in stores, at retailer stores, and do some crazy stuff in combination with AEM if you want to. And I think that's it. That's all we have. Is there
any questions?
Any questions?
No questions.
There in the very back, on the right-hand side, there's a question.
Hi, thanks for the presentation. I'm interested to know about the gateway. Is it just collecting the data from the sensors, whatever devices we have?
The gateway basically has drivers that know about the particular technologies that you use. Yep. And when kind of signals come in through, for example, the wireless radio that is associated with the technology, the drivers push events over the OSGi event bus, and these events basically can be picked up. So the OSGi event admin is like a standard OSGi thing. Any other bundle in the framework can listen to these events and do something with them. Like, for example, anyone in the framework can find out that Carsten was walking through the room because they're just plain events. And then on top of that, we have these functions that allow you to kind of make changes to a device. By sending data to it and controlling it that way.
Good. And who is writing these drivers or adapters to signal the data to OSGi framework?
Who is writing the device drivers?
Yeah.
That could be a combination of people in the community and vendors.
I mean, is it somehow out of the box available for some examples or something?
That's a good question. I'm not sure. I'm pretty sure that they are used commercially by certain companies, but I am not sure how many of them are readily available out of the box. you'd have to do a little bit of research on it. But basically, the standard is called Device Abstraction Layer, and that's that's what they need to implement.
Okay. And if you want to go the non-standard way, I guess it makes sense to to talk about it. There's the Eclipse Smart Home project, which I think provides kind of drivers. It's not using the same interface, but a similar interface. It provides drivers for nearly all devices. No, not nearly. For a lot of devices which are out there. There's so many devices out there, so it would be wrong to say for nearly all of them. But for most of them. And it's OSGi based as well, so you can just plug in these smart home bundles into your OSGi framework and use that stuff.
Any other questions? There's one, yeah.
Hi, thanks. It's been interesting. The question is, usually security is overlooked when talking about IoT. Does OSGi help with that in any way?
Thanks. Yeah, so first of all, I think you're totally right that security is important, and I think in many places, unfortunately, when it comes to IoT, it's overlooked or simply ignored, or just basic concepts are put in place. I don't think that OSGi gives you something special in that term for security. So if you're using OSGi or something else, it's the same thing you have to do to harden your system, right? There's nothing, at least I don't know anything out of the box that comes with OSGi.
You have the OSGi security model, obviously, that exists. But I think in the most cases for IoT devices, the security is implemented on the wire level, like on the protocol. And obviously, the OSGi APIs abstract away from the protocol. So the security would be should be on the lower level. And it's also about over-the-air provisioning. For example, can I over-the-air kind of re-provision an image on this device and turn it into a bot, for example, right? So that is kind of those concerns are more on the lower level, on the actual protocol level. And OSGi doesn't really deal with that, but OSGi does have this service-based security, actually extended Java security model that handles both services and other entities, which is, I think it is used a lot more in the IoT space than it is in the enterprise space. So there is definitely additional features there. So you can basically say this bundle is not allowed to make an invocation on that service, for example. Those types of things are possible to model. But I guess, yeah, it's a big topic, and I'm not sure. I don't think OSGi is going to fix the whole problem.
Thank you. Any other questions?